A newspaper boy is thinking of selling a special one-time edition of a sports magazine to his regular newspaper customers. So there is a newspaper boy who regularly sells newspapers to a set of customers that he has. Now he is trying to sell a special one-time edition of a sports magazine to the same set of customers. Based on his knowledge of his customers, he believes that he can sell between 9 to 12 copies. So based on his knowledge that he has about the customers, he thinks that he can sell somewhere between 9 to 12 copies of the magazine. The magazine can be purchased at rupees 8 each and can be sold for rupees 12 each. So the cost to the newspaper boy will be rupees 8 for each magazine, and the selling price is 12 each for the magazine. So basically, for every magazine that the newspaper boy will be able to sell, he makes a profit of rupees 4 each. Magazines that are not sold can be returned to the publisher for a refund of 50%. So if the newspaper boy purchases a magazine which he is not able to sell, then he can go back to the publisher and return the magazine, but he loses 50% of the value. So what that means is that he is purchasing each magazine at 8 rupees, and if he is not able to sell, when he returns it back to the publisher will give him only rupees 4. So in other terms, he is losing 4 rupees. Now the question given to us is, construct the decision matrix for the above inventory problem, indicating possible monetary consequences. And B, determine the best decision from the standpoint of Maximin criteria, Maxi Max criteria, Hurwicz alpha criteria, assuming that alpha is equal to 0.4, Minimax regret criteria, and Laplace criteria. In the problem given to us, it is mentioned that the newspaper boy believes that he can sell between 9 to 12 copies of the magazine. What this means is that he is anticipating that the demand can be either 9 or 10 or 11 or 12 copies. So in other terms, basically we have 4 states of nature, that is n1 is equal to 9, n2 is equal to 10, n3 is equal to 11, and n4 is equal to 12. Now in order to meet this demand, which is varying between 9 to 12, the newspaper boy has 4 options or 4 strategies that he can adopt. That is, either he can buy 9 magazines or 10 or 11 or 12. So let's say he has strategy S1 is that he buys 9 magazines, S2 is that he buys 10 magazines, S3 he buys 11 magazines, and S4 he buys 12 magazines. Now in order to find the best strategy for the newspaper boy, we'll have to find out the payoffs for each of the strategy to a state of nature combination. Or in other terms, we'll have to build a payoff matrix. Now for each strategy, there can be 4 possible scenarios. Suppose for strategy S1, that is he buys 9 magazine, there could be a scenario that the demand is 9 or demand is 10 or demand is 11 or 12. Similarly for strategy S2, there are again 4 scenarios, that is demand is 9, 10, 11 or 12. So since we have 4 strategies and 4 states of nature, we'll have 4 multiplied by 4 is equal to 16 payoff values. So let us build the structure of the payoff matrix. So we have strategy, that is quantity purchased, which is S1 equals to 9, S2 equals to 10, S3 equals to 11, and S4 equals to 12. And then we have states of nature or events, N1 equals to 9, and 2 equals to 10, and 3 equals to 11, and then 4 equals to 12. There can be two scenarios here. One, that the demand is higher than the quantity purchased. So for example, suppose our demand is 12, but we have stocked only 9. So that is first scenario. Second scenario could be that our demand is less than the quantity purchased. So suppose N is 9, that is our demand is 9, and we have purchased 12 magazines. So based on these two scenarios, we'll have different calculations for payoff. So let's first arrive at a formula. So then we'll use this formula to calculate all the payoffs. Let's assume that S is equal to the quantity stocked, N is equal to the demand, P is profit, and L is loss. So the first scenario is that the demand is greater than or equal to the quantity stocked. So N is greater than or equal to S. So if our demand is greater than the quantity stocked, basically we'll be able to sell all the magazines. Now, if we are able to sell all the magazines, what that means is that we'll be able to make a profit of 4 rupees per magazine. And since we are not returning any magazines unsold to the publisher, we'll not lose any money. So the formula becomes number of magazines sold, which is S, multiplied by the profit, which is P. Now let's look at the second scenario, which is that N is less than S. That is, we are stocking more magazines, but the demand is less. For ease of understanding, let's assume that N is 10 and S is 12. So since our demand is less than the quantity stocked, basically we'll be able to sell all that is demanded. So if 10 was the demand and we have 12 in our stock, we'll be able to sell the 10 that is demanded. So on the demand that we have, we'll make complete profit. So the first part becomes P, that is profit, multiplied by the number that we are able to sell, that is N. Now for the remaining amount which we are unable to sell, which in this case is 12 minus 10, which will be 2. Basically, we'll go to the publisher and return it back. Now, in the problem it is given that if we return it back, we get only 50% refund. So we are losing 50% of the purchase price. So our loss becomes 12 minus 10, that is the amount that we are unable to sell, multiplied by the loss. So since we have designated loss as L, we'll put minus L multiplied by the differential, that is the number of magazines that we are unable to sell. So S minus N. So this is our second formula. So let's take an example of each of these cases and see how you can calculate all the payoffs. So for the first scenario, let's take N is equal to 10 and S is equal to 9. So here you can see N is greater than S. So since our demand is higher than the quantity stocked, we'll be able to sell all the magazines that we have. So our payoff becomes S, that is 9, multiplied by the profit. Now the profit for each magazine in the problem is given as 4 rupees because the selling price is 12 and the cost price is 8. So 12 minus 8 is 4. So 9 multiplied by 4, which is equal to 36. Now for the second scenario, let's take N is equal to 10 and S is equal to 12. That is, we have stocked 12 and the demand is for 10. So in this scenario, we'll be able to sell whatever is the demand, that is 10. So 10 multiplied by the profit. Profit is 4. So 4 minus. Now it has been given in the problem that for each magazine which we return, we get a refund of 50%. That is, the purchase price is 8. So we'll get only 4 rupees back. So we are losing 4 rupees. So L is 4. So 4 and multiplied by the differential, that is 12 minus 10, that is 2. So this equals to 40 minus 8 is equal to 32. Similarly, if we continue calculating all the payoffs, we'll get the following values: 36, 32, 28, 24, 36, 40, 36, 32, 36, 40, 44, 40, 36, 40, 44, 48. The first criteria is Maximin criteria. Maximin criteria is the criteria where the decision maker tries to find the best of the worst, or in other terms, maximum of the minimums. So first you find the minimums, that is, what is the worst that you'll get for each of the strategies, and from all the worst you then find the best, that is the maximum of those. So to be able to make a decision based on Maximin criteria, Let's first construct the payoff matrix that we achieved in the previous step. So we have strategy, that is S1, S2, S3, and S4. And we have events, N1, N2, N3, and N4. 36, 32, 28, 24, 36, 40, 36, 32, 36, 40, 44, 40, 36, 40, 44, 48. Now let's find out the minimum payoffs for each of the strategies. So minimum payoff for first, everything is 36, so 36. For second strategy, minimum is 32, so 32. For third, the minimum is 28, and for fourth, the minimum is 24. Now Maximin criteria is to find the maximum amongst the minimums. So from the minimums, 36 is the maximum, so Maximin is 36. That is to choose strategy S1. Now let's look at the second one, which is the Maxi Max criteria. Now the Maxi Max criteria aims at the best of the best, or in other terms, first to find the maximum of all the strategies, and then finding the maximum amongst the strategies. So finding the maximum of the maximums. So to decide based on the Maximax criteria, let's build the matrix. So we have S1, S2, S3, S4, N1, N2, N3, N4, 36, 32, 28, 24, 36, 40, 36, 32, 36, 40, 44, 40, 36, 40, 44, and 48. Now let's first find the maximum payoff for the strategies. So max payoff. So for the first strategy, everything is 36, so 36 is the maximum. For second strategy, 40 is the maximum. For third, 44, and for the fourth, 48. Now we have to find the maximum of the maximum payoffs. So Maximax. Now the maximum is 48. So basically we have choosing strategy S4. Now let us look at the third criteria, which is Hurwicz alpha criteria. Now the Maximin and Maximax criteria are the two extremes on the scale of optimism. Maximin representing pessimism, while Maximax representing optimism. So Hurwicz alpha criteria comes up with a midway approach by adding a coefficient of optimism called alpha. The value of alpha can be between 0 and 1, the value of 0 implies pessimism, while the value of 1 represents optimism. So in order to decide using the Hurwicz alpha criteria, let's first draw the payoff matrix. So strategy is S1, S2, S3, and S4. Events N1, N2, N3, and 4. Thirty-six, 32, 28, 24, 36, 40, 36, 32, 36, 40, 44, 40, 36, 40, 44, and 48. Now, for the Hurwicz alpha criteria, we have to first find out the expected monetary value for each of the strategies, and whichever strategies has the maximum expected monetary value, that strategy will be chosen as the optimal strategy. Now, in this problem, alpha has been given as zero point 0.4, and the formula for calculating the expected monetary value is alpha multiplied by the maximum payoff, that is capital M, plus 1 minus alpha multiplied by the minimum payoff, which is small m. So here we know alpha. Now we have to calculate capital M and small m. So let's do that. So capital M, that is the maximum payoffs. So the maximum payoff for strategy S1 is 36, S2 is 40, S3 is 44, and S4 is 48. Let's calculate small m, that is minimum payoffs. So for S1 it is 36, S2 32, S3 is 28, and S4 is 24. Next we'll calculate the EMV, or the expected monetary value. So for first case it will be 0.4 multiplied by 36 plus 1 minus 0.4, that is 0.6 multiplied by 36. This is equal to 36. Similarly, if you continue calculating all the expected monetary values, you'll find the following value. That's 36, 35.2, 34.8, and 33.6. Now, based on the EMVs, strategy S1 has the highest value of EMV. So our optimal strategy will be to choose S1, that is buy 9 magazines. Now let's look at the fourth criteria, which is Maximax regret criteria. Regret represents opportunity lost. So for each of the demands, if we did not choose the best strategy, then how much would be the regret or opportunity lost for all the other strategies for that particular event or demand. That is the regret. So once we calculate all the regrets, what this criteria says is find the maximum of the regrets. So find the maximum of the regrets for each of the strategies, and then find the strategy which has the minimum of all the maximum regrets. So then second is to find the minimum amongst those regrets. So let's first draw the original matrix, that is strategy S1, S2, S3, S4, and events N1, N2, N3, and 4, 36, 32, 28, 24, 36, 40, 36, 32, 36, 40, 44, 40, 36, 40, 44, and 48. Now, based on this, let's create a regret matrix. So, strategy S1, S2, S3, S4, and events N1, N2, N3, and 4. So let's take the first state of nature or event, that is N1. For N1, based on all the payoffs of the strategies, the best strategy would be S1 because the payoff is maximum. However, suppose we do not choose strategy S1, that is our payoff is 0, and if we choose strategy S2, then basically we are losing 36 minus 32, that is 4, as the opportunity lost. Similarly, in case of choosing S3 instead of S1, the regret or the opportunity loss is 36 minus 28, which is 8, and in case of S4, 36 minus 24, which is 12. Similarly, for N2, the best strategy is S2. However, if we do not choose S2, then for S2 we'll put a 0. If we choose S1 instead of S2, we are losing 4. If we choose S3, again we lose 4, and if we choose S4, we lose 8. Similarly, for all the other events, the regret is 8, 4, 0, 4, 12, 8, 4, 0. Now, as indicated earlier, first you have to find the maximum of the regrets. So, max regrets. So, for S1, maximum is 12. For S2, it is 8. For S3, it is 8. And for S4, it is 12. Now, out of these maximum regrets, basically we want to minimize the regret and find the one which is the minimum, because that then will be the best strategy. So mini max. So out of these, 8 is the minimum and 8 is the regret for both S2 and S3. So the optimal strategy as per the mini max regret criteria is that we can choose either S2 or S3. Now let us look at the fifth criteria, which is the Laplace criteria. Laplace criteria suggests that if we do not know of any reason for one event to occur more than the other, we should assume that all events have an equal chance of occurrence. So in order to decide based on Laplace criteria, let's first draw the payoff matrix. So strategy S1, S2, S3, S4, events N1, N2, N3, and N4. 36, 32, 28, 24, 36, 40, 36, 32, 36, 40, 44, 40, 36, 40, 44, 48. Now since here there are 4 events and each has to assume a equal probability of occurrence, the probability of each event to occur is 1 by 4. So for each strategy, let's calculate the expected monetary value, which is nothing but the addition of the products of the probability with the payoffs. So for S1, the EMV will be 1 by 4 multiplied by 36 plus 1 by 4 multiplied by 36 plus 1 by 4 multiplied by 36 plus 1 by 4 multiplied by 36. This is equal to 36. So let's put the value of EMV in the matrix. So for S1, the EMV is 36. Now let's calculate the EMV for second strategy. This will be equal to 1 by 4 multiplied by 32 plus 1 by 4 multiplied by 40 plus 1 by 4 multiplied by 40 plus 1 by 4 multiplied by 40. So 1 by 4 multiplied by 40 is 10 plus 10 plus 10 30, and 32 divided by 4 is 8, so 38. Similarly, EMV for third is also 38, and EMV for fourth is equal to 36. So let's put these values in the matrix. For S2, EMV is 38, for S3, 38, and for S4 is 36. Now the maximum EMV is obtained by strategies S2 and S3. So based on Laplace criteria, again the decision could be to either choose S2 or S3.